6 people are invited to attend a 5-day conference scheduled for Monday through Friday. So first thing on these day of the week problems, I always like to write out the days of the week. So draw out the 5 slots for the 5 days of the week. Grace will attend only on Monday and Thursday. Becca will attend every day except Monday. Carmen will attend every day except Thursday. Ernie will only attend either Thursday or Friday. So I'll put him in parentheses. He's going to attend either Thursday or Friday. Frank will attend every day except Monday and Wednesday. On how many days during the conference will at least 3 of the 6 people be in attendance? Well, Tuesday, there's going to be 3. And Thursday and Friday, it doesn't even matter which day Eddie comes because there's going to be 3 people regardless. So Thursday and Friday, there'll be 3 of the 6, at least 3 of the 6. So in total, that's 3 days. Number 58. The bus from Kevin's home to the middle school travels 8 miles west, then turns and travels 8 miles north, then turns and travels 7 miles west to arrive at school. If the bus were able to travel directly from Kevin's house to the middle school along a straight path, how much shorter would the trip be? So let's draw out this straight path. I'm trying to make it straight. And okay, so that's our straight path, this blue shortcut. How much shorter would that be? Well, first, we know that the original path is 16 plus 7, so that's 23. So if we can find the distance of the blue path, we can subtract that from 23 to find how much shorter it would be. And this is a very tricky one because we have to use the Pythagorean theorem. We have this slanted line. So let's draw out these 2 sides and make a right triangle. So here we have a right triangle. And if we know the 2 legs of the right triangle, we can find the hypotenuse using the Pythagorean theorem. So this vertical leg is just 8, right? Same as that distance. And this horizontal leg is 8 plus 7, so that's 15. So we have a right triangle that's 8, 15, and then we don't know the hypotenuse, but we can find that using the Pythagorean theorem, which tells us a squared plus b squared equals c squared, where a and b are going to be 8 and 15 in some order, and c will be this hypotenuse, which is the shortcut. Now, on warm-ups, you can't use a calculator, so it's a pretty good bet when they give you Pythagorean theorem questions. They're going to give you one of the famous triplets, where each of the legs is a whole number. And I know that if I have a right triangle with legs of 8 and 15, the hypotenuse is going to be 17, because that's a famous Pythagorean triplet. 8, 15, 17. And if you do out the math, you can verify that if you do 8 squared plus 15 squared, we're going to add those up. That's 225 plus 64. That adds to 289. And 17 squared is 289. The square root of 289 is 17. So the shortcut is 17, and the long way is 23. How much shorter would it be? 6 miles. All right. That was a really nice one. I like that problem. 59. When 21.5 trillion is written in scientific notation, what is the exponent needed on the base of the 10? Well, first let's write out this number. So, okay, that'd be 1,000, million, billion. I didn't plan out well, so I'm going to add the zeros over here. Okay, so we got thousand, millions, billion. Here would be the trillions place. So 21.5 trillion would be 21, and then this would be a 5. So that's 21 trillion, and then another half trillion would be 500 billion. Okay, 21.5 trillion. When that's written in scientific notation, what is the exponent needed on the base of 10? So in scientific notation, the first number has to be between 1 and 10. So in this case, it would be 2.15, and then times 10 to a certain power. Well, how many times would we have to multiply by 10 to get the decimal from 2.15 all the way over to here? Well, 3, 6, 9, 12, 13. 13 times, because there's 13 places in between here and here. So that's our answer. 13 would be the exponent needed on the base of 10. Final problem, number 60. If a polygon has 17 sides, how many diagonals does it have? So I'm going to be honest, I didn't really have a clear idea of how to do this. So I just started investigating. So let's say we have a polygon with 4 sides. How many diagonals does it have? 1, 2. Then I started making a chart. So sides, diagonals. 4 sides, there's 2 diagonals. All right, what if there's 5 sides? We're going to have 1, 2, 3, 4, 5. 5 diagonals if it's a 5-sided shape. All right, now what if it's a 6-sided shape? One, 2, 3. Let's move up to the next vertex, try to keep it organized. 3, 4, 5, 6. Move over to the next vertex. Oops, different color. We're at 6, 7, 8. Move over to the next vertex. 9. And if I look at the next vertex, all the diagonals are already drawn. So, if it's a 6-sided shape, there'd be 9 diagonals. Now I have enough data points where maybe I can find some kind of pattern, right? Well, here went up by 3, and here it went up by 4. And actually, if I look at a triangle, right, there's no diagonals you can draw on a triangle. So that would be 3 sides, 0 diagonals. And to go from 3 sides to 4 sides, the diagonals increase by 2. So look, plus 2, plus 3, plus 4. I'm going to hypothesize that a 7-sided shape, we would add 5 to get 14 diagonals. And I'm not going to draw that out. I think that's a little bit beyond my skills, but I'm pretty confident that this pattern is going to work. So a 7-sided shape would have 14, and now we got to get all the way to a polygon with 17 sides. So I'm going to continue applying this pattern. See, add 5, now add 6, add 7, add 8, add 9, add 10, add 11, add 12, add 13, add 14, and finally add 15. And we get 119 diagonals. Now when I check this with the answer key, it is correct. So this pattern does work. There is an easier way. There's a formula you could look up to find the number of diagonals in a polygon with a certain number of sides. But I actually like showing you guys this solution because sometimes you won't know the formula. And one thing you can do in that case is just start investigating. See if you can find some kind of pattern that will allow you to solve the question it's asking. And when you're looking for a pattern, make sure your work's organized in some kind of table. So if there is a pattern, it will become apparent to you.